while we're waiting for the recording to start. All right. Make sure you've got your notes with you, all that good stuff. We are going to be writing down the properties first because we want to be able to identify our properties of equality. And then once we do that, we're going to move into looking at examples of those properties of equality and kinds of problems that you might see where you would want to be able to use them to justify steps. So let's see. Here we go. Put the light on. Let's see if that helps. Okay. Anyway, 2.4. Wow, spelling. TIES, algebraic properties, and a little bit of proof that we'll get into. All right. So we're going to kind of set up kind of 3 columns here in our notes. We're going to have the name for the property in one column. We're going to have kind of the definition and the generic equations that we use in the middle. And then we're going to have a specific example on the right. So we're going to go the name of the property, the definition / equation, and then example. Okay, so go ahead and set up your notes like that so we can get our properties down. Okay, and so for pretty much all of these, they're going to be the something property of equality. So I'll write out property of equality once, but then after that, we're just going to abbreviate it as POE because writing property of equality like 10 times gets old fast. So here we go. The first one is the addition property of equality. And from here on out, we are abbreviating it as POE, property of equality. Okay. So the addition property of equality is what lets us add something to both sides of the equation. So for example, or the definition of it anyway, is if A equals B, then A plus C equals B plus C. So I can add the same number to both sides of my equation, and that's okay to do. So there's our example, or our definition, I guess. Then our formal example, if we've got an equation like x minus 3 equals 4, how would I solve that for x? I'll just add 3 to both sides, right? So when I go plus 3 on both sides, this is where we're using the addition property. So we get x equals 7. So that's where we're using that addition property. So if I was asked to justify that step, I would put addition property. That's my justification. That's what tells me that I can add something to both sides, and that's, you know, it stays equal. Okay. Next one, we've had the addition property. Now we've got the subtraction property. So we've got subtraction, POE, for property of equality, which is way nicer to write then writing out all of that property of equality. And so it starts off very similar. We have if A equals B, then A minus C equals B minus C. And so our example is going to go very similarly. If we have x plus 4 equals 12, well, how would I solve that? Just subtract 4 on both sides. And that subtracting 4 on both sides of the equation is the subtraction property at work. All right, so we have addition, we have subtraction. We're also going to have multiplication and division. And it starts off very similarly. If A equals B, then A times C equals B times C. So our example there, we're going to have x over 3 equals 4. Well, to solve this, I would need to multiply by 3 on both sides. So I would go times 3 times 3. That multiplying by 3 is the multiplication property. All right, so we have addition, subtraction, multiplication, and now we have division. All right, division property of equality. If A equals B, and then division has one extra thing on it. There's this caveat, and C is not equal to 0. Then A divided by C equals B divided by C. And why can't C be 0? Anyone know? What would happen if C was 0? Can we do that? Yeah, you can't divide by 0. Thanks, Nolan. Right. So that's the only reason that C can't be 0 here. That's why we have to add that little extra bit about C not being 0. Okay, so the division property is a common one that we end up using because we get stuff like 2x equals 16. And then to solve this, we have to divide by 2 on both sides. That's the division property. And so we're left with x equals 8. So that's the division property. Okay, so we have addition, subtraction, multiplication, division, all those operational properties. Then we're going to step into a little bit more of one that you might have learned in middle school or in algebra, the distributive property. All right. So the distributive property is that if you have A, parentheses, B plus C, then you can multiply the A by both the B and the C. So we go swoop, swoop. They both get the multiplication. We're left with A times B plus A times C. Okay, so that's the distributive property. And for example, with actual numbers, we could see something like 3 times x plus 2. And so if I was using the distributive property here, we would get 3x plus 6 because we have 3 times x plus 3 times 2. Okay. So there's the distributive property. We got a couple more properties to go here. Now we've got the substitution property. And we're going to say POE, property of equality there. Okay, the substitution property says if x equals y, then x can be substituted for y in any equation. If x equals y, then x can be substituted for y in any equation. All right. So the way that we see this used is when we're combining like terms. A lot of times you'll see that in algebra if you're combining like terms. So for example, if we had x plus 2 equals 3y plus y minus 7 or something like that. Or we'll say 3x plus 7. We'll make it something more realistic there. 3x plus 7, or minus 7. Blah. Okay, so if we have something like that, my first step to solve that equation would be to combine my like terms, right? So we'd get 4x minus 7 over here, right? So here, we took 3x plus x, substituted, 4x instead. So we took 3x plus x and we substituted 4x instead because those are equal, right? So that would be substitution. We'll also see that if you were to go and take a value for x and plug it back in to an equation and stuff like that, that's all substitution there. Okay. We have 3 more properties here. 3 more. So here we go. Extend the lines. Okay. We have the reflexive property of equality. Yes, I can slow down. Yeah, that last one had a lot more writing in it. Okay, so our next one is the reflexive property of equality. All right. The reflexive property, I kind of sometimes refer to it as the duh property. It's that something is equal to itself. And you might think, well, of course, something is equal to itself. X is equal to X and Y is equal to Y, and things like that. So the reflexive property of equality is that A equals A. So, examples of the reflexive property are going to kind of follow the same way. 15 equals 15. Measure of angle 1 equals measure of angle 1. Segment AB is equal to segment AB. Those are all examples of the reflexive property. Okay. So we usually see that one when we're talking about triangles and showing that two triangles are congruent and stuff like that. So we won't use that one a ton until we get there. The symmetric property, though, is one that you see a little bit more often in algebra. So that's our next one here. Symmetric property of equality. Okay, so the symmetric property says if A equals B, then B equals A. It's that thing that says you can switch the order. So if it helps you to think of it this way, symmetric starts with S, switching starts with X. Symmetric is switching. Symmetric switching. Okay. So that's what lets me go if A equals B, then B equals A. So if you end up with, at the end of your equation or something like that, you have 2 equals X, then you can switch it around and say X equals 2. So that's my justification for being able to switch the order there. It also works for if you're saying like, you have segment AB is the same length as segment BA. Those would all be things that you can justify by the symmetric property. Okay. Last one. Transitive property. Transitive property. If A equals B and B equals C, then A equals C. So there's a couple ways you can think of this one. You can kind of think of it as like B is the middleman. They have this in common, right? So if A is equal to something and that same thing is equal to C, then A must also be equal to C. Another way I like to kind of think of it as it applies in nature. If let's see, if a bear is chasing your friend and your friend is chasing you, then by the transitive property, the bear is also chasing you. Anyway, so that is the transitive property. So the way that you'll sometimes see it algebraically, maybe you'll see something like y equals 3 squared. And 3 squared equals 9. So y equals 9. Basically, you're cutting out the middleman here and going directly to the end. Okay, so those are all of our properties. This is a good list to have, especially with all of the examples and everything, so that you can kind of You know, if you need to go back and compare with your notes to identify one of them, you can. So we're going to do a couple of examples of things, places that you might see these properties, ways you might be asked to identify these properties and things like that. So here we go. Getting another piece of paper here for examples. Okay, so we might see problems like this where you're given a statement and you have to identify which property goes with that statement. So we might say something like, our first one, if measure of angle 1 equals measure of angle 2, then measure of angle 2 equals measure of angle 1. And then we have to think, okay, which property does that go with? What did we do here? So looking back at my list of properties, well, let's see, we went from angle 1 and angle 2 to angle 2 and angle 1. We just switched the order. Which property was it that told us we could switch the order? Look back at your list and type it in the chat. What do you think? Yes. All right. Yep, you're right. Symmetric. So if you look at symmetric property, that was the one where A equals B, then B equals A. So you switch the order. That is symmetric. All right, another one. If we had if x equals 3, then x plus 2 equals 3 plus 2. All right, so what's the difference between this one and this one? Well, we just stuck a plus 2 on there. So what would our property be if we are adding something to both sides? Yep, addition property. So we might be asked to identify the property like that. Another type of example of a problem that we could see is they'll start off a statement and then we have to finish it. So they might say use the transitive property to complete the statement. So we might have to fill in the blanks of a transitive property statement here. So if measure of angle 1 is equal to measure of angle 2, and measure of angle 2 is equal to measure of angle 3, then these are the ones that are the same. And so you take the ends and set them equal. measure of angle 1 equals measure of angle 3. So we're cutting out that middleman of angle 2. Okay. The last kind of question that you'll see is something where you're given an equation to solve, and then you have to use properties of equality to justify all of your steps. So we'll do a couple of those as well. So we'll be given an equation like -5 equals 3n plus 1. And we have to use our properties as we solve this equation to justify all of our steps. So the way that you're going to see it most often is you'll start with equation steps over on one side, and you'll have a justification over here. And so you'll get like these two columns. And so your first step is always to put the equation out there that you're given. So -5 equals 3n plus 1. That's what we start with. And your first justification is always just the word given, because they gave you that equation. So just something to know, always start with given info. Okay, so if I was going to solve this equation, well, I would probably subtract 1 from both sides, right? Because I want to get just n over here and everything else over here. So my second step would say that -5 minus 1 is -6 equals 3n. Well, what did I do here? What property was it that I used to subtract 1 from both sides? Subtraction property. So over here on my justification, I would just say subtraction property. Because that's what I did in my step. So I'm basically going through and solving the equation and then telling them about my steps, telling them what I did on each of them. So what would my next step be to solve this equation? So if I have -6 equals 3n, what do I have to do to get rid of the 3? Yeah, divide, Owen. We would divide by 3 on both sides to get rid of that 3. And then -6 divided by 3 is -2. And so since we divided on both sides, this would be the division property of equality. And then lastly, we want to just switch the order really quick so that we get a statement saying n equals something. And that property that said I could switch the order, well, that was the symmetric property. And then we're done. We've solved the equation. We've shown our steps. We've given reasons for each step. So we're all done. Okay. So sometimes we'll see problems like that as well, where you're asked to justify each of the steps that you took to solve an equation. Okay. So with this, we're going to, let's first of all, I guess, any questions, any steps we're not sure why they happened, or things that don't quite make sense? Any numbers or things we're not sure where they came from? Okay. If there are at any point, either say something in the chat or unmute yourself and say so, because we're going to move into the assignment in just a moment. I'm going to post it here. Give you a chance to finish writing if you haven't. Okay. So today's assignment has two parts. It has a big ideas part and it has an IXL part. I'm going to go over a couple of the big ideas problems with you guys just because there's a lot of clicking and dragging and stuff, and we want to make sure that we know what we're supposed to do with those. So we've got big ideas and we have one IXL section. We'll start with the big ideas. So if you want to click on the link and follow along in your big ideas, you can. You're getting a free answer here, or a couple free answers. If not, then, or if yours doesn't work at the same time as a Google Meet, that's okay. Just follow along here. And then when you leave the Google Meet, you can do it on yours. So first, we've got the multiplication property of equality. We want to use the property to complete the statement. So we have AB equals CD, then 5 times AB equals blank. So if we're supposed to use the multiplication property of equality here, we multiplied by 5 on this side, so we need to multiply by 5 on the other side, which was with the CD. So I would drag 5 times CD up there. We check our answer, and yay, we're correct. If you were wrong, you would want to switch it out and try something different. But that's what we're expected to do there. Okay. The next question says to name the property of equality that they're using here. So we have if x equals y, then y equals x. Well, that looks a whole lot like, if we look back at our sheet of properties, that looks a whole lot like the symmetric property where you're just switching the order. So you click the drop down, you go, okay, we got all these options. This one looks symmetric to me. And you check your answer and we're correct. So that's another type of problem you'll see on here. And then the last type is like this, where you're writing the equation and then explaining what you did on each step. Okay. And so the only hard part about this one on big ideas is that you're kind of looking through at the steps and trying to figure out what they did next instead of what you might do next, since there's a lot of different possibilities when you're solving equations algebraically. So the hard part is figuring out what they did next. Okay, anyway, we've got these 4 options for steps. And so let's see. And they want to solve the equation for y. So this is nice. We know that we're solving for y. We want to get y by itself at the end. Okay. So what I would probably do next if I were them is move the 7 over to this side because we want to get y by itself, right? So is there anything down here that has the 7 moved over to the other side? It turns out this one right here. It looks like if they added 7 to both sides, they would get this. And it tells you over here what you're supposed to use, so that can kind of also give you a clue. You're supposed to use the addition property of equality by adding 7 to each side. So here we're supposed to use the division property next. Is there anything down here that talks about dividing? It says divide each side by 9. So that'll be my explanation. And then in my problem here, I would divide by 9 on both sides. Well, 3 divided by 9 is, or 3x divided by 9 would be 1/3 x. 14 divided by 9 would be 14 over 9. So that would be that step. And then the last step, they're just rewriting the equation. They're switching it around so that you can get y on one side and all the other stuff on the other side. They're using the symmetric property to rewrite the equation as a y equals something. Okay, and then like always, we want to check and see that we got them all right. If we didn't get them all right, if we only got like, if one of them was wrong or something, make sure you switch it out and try again. So that's going to be the harder type of question you'll see on here. And again, there's not a ton of them. But yeah, so there's that type of question as well. Then the other thing we have for this assignment is the IXL section. And the IXL should be a little bit easier. It's only dealing with addition, subtraction, multiplication, and division. So it's multiple choice. You're picking from one of these four for all of your IXL questions. And so you look at the first one and you go, okay, here's our first step and here's our second one. What's the difference? Well, they did a minus C over here and a minus C over here. So that would be subtraction. All right. And so over here, they did 28 times 18 instead of just 18. And we have 28 times negative 54 plus k. So they multiplied by 28 on both sides. So that would be multiplication property. Or here's our original equation. Here's our new one. They divided by 16 on both sides. So that would be division property. So that's how all of those IXLs are going to go. Okay, so this is the part where if you have questions or need help with anything, feel free to stick around. Otherwise, you are free to go and work on the assignment. We do not have HSBP today, so you will not need to come back to the Google Meets. In a couple minutes, I will post the exit ticket for you so that you can complete that before you completely leave class for the day. But otherwise, have a good one.